Okay, now we look into this question. A student accidentally spilled the hydrochloric acid. Okay, so hydrochloric acid, okay, on the floor. So it shows the condition of the floor. Okay, here, class. Okay. And now this is the floor tile. So in the medium here, actually, if you observe on your, now in our class don't have lah, but at your home, between the tile there is a like a hole, right? Inside there, do you know what is the content of that? Cement? Is it cement? Okay, actually it's a limestone filler here. Okay, so class, what is limestone? What is the limestone, class? Calcium carbonate, yes, calcium carbonate. So you can record down, this is calcium carbonate. Okay, it's a calcium carbonate. So here the hydrochloric acid, it will react with the calcium carbonate. Then it will produce what? Bubble gas. Okay, so what is this gas? Is it hydrogen?
No.
What is the gas?
Carbon dioxide.
Yes, here if you look into this carbonate, so you know this is a carbon dioxide gas. Okay, so basically we will able to answer the question already. State the type of acid for the hydrochloric acid. So it is 3 marks here, right?
No.
So okay, what type of acid for the hydrochloric acid? Okay, it's a strong acid. So 0.1. You can write it's a strong acid. Okay, so it is a strong acid, or you also can mention it is a monoprotic acid. Strong monoprotic acid better. This is the best. Okay, now point number 2. Okay, here. Explain the observation obtained. Here the observation is bubble gas produced, right? Okay. But here if you write bubble gas release, it will be no marks. So you have to explain what is that. Okay, yes. Point 2, you can write carbon dioxide gas release. Okay. So point number 2. Okay, now why? Why it has the point, it has the carbon dioxide gas release? Okay, so this is hydrochloric acid react with limestone. Yes. Okay. So in exam, you can write like this: 1, 2, 3. So 3 marks, right? So 0.1, 0.2, 0.3 like this. So you label this is A. Okay on that. Any question? No. Emphasis, okay? Adrian? Can This is how you can make a higher score in the exam. Okay, now B. Okay, in another experiment, okay, diprotic acid H2X. Now we know it is a diprotic acid already. Okay, react with potassium hydroxide solution. Okay. So here actually we already know there are not many examples that we know is the diprotic acid. Correct? So what is the most popular diprotic acid we know? Sulfuric acid, H2SO4. Okay? So first, the question here, write a chemical equation for the reaction. Okay? So 7 marks here. So equation will be 2 marks already. So 0.1 and 2 will be the equation. Okay. So chemical equation, you can replace with sulfuric acid, or you just remain it in the H2X also can. So H2X react with what? Potassium hydroxide, KOH. Okay, then you produce KX and sorry, should be K2X, correct? Should be K2X. And then water. Then we need to balance the chemical equation. How?
2 to the 12.
Okay, potassium hydroxide times 2 here. Then, okay, H2O also. Yeah? So point 1 and point 2, all formula correct, 1 mark. Then, balancing, 1 mark. Okay, not? If one of the formula wrong, point 1, point 2, no more. Okay, no more. Okay, now point number 3. Okay. Determines the concentration of the acid used. Okay, class. If we want to use if we want to find the concentration of the acid, here is the acid, right? Okay. So this is neutralization, right? So there is few ways to find this, but I will encourage you all to use the formula. What formula? To find the concentration, we use what? We use MA VA over MB VB equals to A over B. Okay, so A is refer to which one? A for acid. Okay, B for alkaline, alkaline or base. Okay, so we replace in all the information. MA, you need to find, right? So MA we don't know. Okay, VA, volume of the acid. Okay, 25. Right? Okay, next. MB, 0.01. VB, 50. Okay, that? Now A. This A and B refer to what? Refer to the mole for the acid and alkali. So acid is this one, is 1. Okay, B refer to here, so it's B, so it's 2. Is that okay? Now, can you try to find out what is the MA, the concentration of the acid? So what is the MA? Pardon? 0.01. You will get 0.01. Everybody, you get the correct one? Yeah. Okay, you use the cross multiply. Okay, cross multiply. So finally, you get a MA is 0.01 mole per cubic decimeter. Okay, that? Okay, now class, there is one thing is tricky here. If MA now, the sulfuric acid or H2X is 0.01 mole per cubic decimeter. Okay, the question asks you to find the pH, right? Okay, pH. So what is the formula to find the pH? Okay, pH is negative log concentration of hydrogen ions. Okay, do we use the concentration of the sulfuric acid here, 0.01 mole per cubic decimeter? Huh? Yes or no? No, why? Okay, why? Because sulfuric acid is diprotic acid, right? Okay, so in other words, you see, if we make it like this, okay, if we write out the equation, the ionization, so H2X, when it ionizes, it will produce what? 2 moles of hydrogen ions and 1 mole of X, correct? So meaning that if now the sulfuric acid is 0.01, okay, then how about this? 1 to 2, right? Okay, meaning that here now is 0.02 mole per cubic decimeter. Okay, so your concentration here, it should be double. Okay, right? So use your calculator. Negative log 0.02. Okay, so what is the value? What is the value? 1.7. Okay, so the pH is 1.7. Okay, any question, class? Okay. Okay, Adrian, remember, record down, huh? Okay. Faris, already? Okay, sila salin dalam. Then what? Okay. Now question number 4. Question C. Okay, diagram shows a flow of reaction that occur on the outside of metal P. Okay, so metal P put into the hydrochloric acid. Okay, and then the mixture is filtered. It forms a K ions R and N ions S. Right. So here got a very important clue. Here is a blue solution of Q. So class, if we see the blue solution, what is the ions that are present? Couple, so we will know this is a couple already. Couple 2 ions, right? Okay, but we don't know what is the S. Okay, but if like this, we will know. Okay, if react with the hydrochloric acid, so basically we will know this one. What is the oxide here? Couple 2 oxide, no? So couple 2 oxide react with hydrochloric acid. So what is the product? It's a neutralization, right? So what is the salt? It's a couple 2 chloride and water. Okay, so this one is HCl, right? Okay, so the equation here times 2 lah. Okay, then couple 2 chloride undergoes a reaction 1, react with lead 2 nitrate. So lead 2 nitrate, Pb, lead 2 nitrate. Okay, it will form what? White precipitate. So what is this white precipitate? Yeah? What is the products? Yeah, Joanne? What is the products? The white precipitate here. Which one is an insoluble salt? Lead what? Lead 2 chloride. So lead. This one will precipitation, right? So chloride. Lead 2 chloride. And another one is what? Blue solution. So couple lah, right? Couple 2 nitrate. Okay. Okay. So couple 2 chloride react with lead 2 nitrate. Okay. So if we know the flow chart, everything, then we can, I think we should be able to answer the question already. Okay. Based on the diagrams, identify the name of the reaction 1. Okay. So how do we write the answer for this? Okay. So let's say point 1, we want to answer what? So better we write like this, reaction 1. Okay? Reaction 1, what is the reaction called? This is the reaction 1, right? What is this reaction called? Precipitation, right? Precipitation. Or also called double decomposition. Okay? Now, point number 2. What are the following question? Identify the metal outside metal copper. Okay. So what is the metal oxide? Can I write CuO? Can or not?
Yes.
Huh?
No.
Yes or no?
Yes.
Okay. Cannot because here. So be careful. Name here. Okay. So you must write the name. So this one is rejected. Cannot. So you must write down copper 2 oxide. Okay. So I think we better write the correct one. Okay. So P. P. Okay. Now point number 3. What else? White precipitate T. So T. What is the T? Lead 2 chloride. Right? Okay. Then point 4. Blue solution U. U is this one, right? So it's what? Copper. Roman 2 must put in copper 2 nitrate. Okay, now we have 4 marks already. 4 marks. Okay, now another 6, right? Okay. Describe a chemical test to verify the anion S. So anion S we know already. This is what? Chloride. Then R is copper. Okay, so roughly is anion 3 marks. Okay, ion 3 marks. So total is 6 marks. Okay, so we can write down like this. Test for K ions R. Okay, how to test the K ions copper class? How to test the K ions? Although we know when we look into the colors, right, it is copper 2, but it's not the test by observing it. So we have to carry out a list of the chemical tests to verify it is really the copper 2 ions, right? So normally what we use? What we use? Brenda? For all the K ions, sodium hydroxide solution, okay, plus the ammonia, right? Okay, so first, okay, 8. Okay, sodium hydroxide solution into test tube containing solution Q. Okay. We can say until SS or not? Yes, right? Until SS. Okay, now pen number 6. Okay, blue solution, blue precipitate, right? Blue precipitate is formed. Okay, so point number 7, copper 2 ions is present. Okay. Then this one you also can replace it with ammonia. It's up to you. Okay. See which one you can remember. Okay. But I think you all should remember for all the tests. Because you just memorize the observation for it. Then it will be easier if the question from the short coming out in the essay question. Okay. Now another 3 marks is a test for anions S. Okay, so class for anion S is a chloride. So chloride, what is the chemicals that we use? Nitric acid followed by silver nitrate. You will see what? White precipitate. What is that white precipitate actually? Chloride ions actually is what? Silver chloride. Because we use the silver nitrate, right? Okay. So we use what? This one we use a nitric acid, A inverse, then silver nitrate. Okay. Then you see white precipitate. Okay. So point number 8. Okay. Add okay, so class, for this one, normally if we want to include the volume of all these tests or all these chemicals, so what is the volume we should use? 2, every time we use 2, standardize it. So meaning that this one add 2 cubic centimeter, okay, into the test tube containing the solution. So this one also the same, add, okay, of nitric acid, okay, follow by 2 cubic centimeter of silver nitrate solution, okay, into solution Q. Okay, point number 9. What can you observe? White precipitate, right? White precipitate is formed. Okay, then point number 10. Chloride ions is present. No S, okay. Okay, so this is how we write the correct, or try to write up the correct points for the marks allocation in the exam. Okay, not? So for the trial questions, I will encourage all of you to try all the essay question. Okay. Okay, we look at question number 10. Diagram shows the study of the redox reaction. Okay. So you see here, this one chemicals, hydrochlorine, water, put into, set 1 is put into the potassium iodide. Set 2, put into iron 2 sulfate solution. Okay? So, like this case, you should know one must be oxidation, one must be reduction. Okay, not? So roughly will be like this. Now, okay, we look into set 1 first. Class, set 1. Okay, the chlorine put into potassium iodide solution. Okay. What is the products? So, is the chlorine able to displace the iodide?
Yes.
Yes, it is more reactive, right? The displacement of halogen. Okay, so what is the products? Potassium chloride. And what is being displaced? Iodine. Yes. Okay. So it's not balanced. So we need to balance the equation. So this one is 2. This one times 2. Okay. 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 Now number 2. Okay. Same chemical chlorine put into iron 2 sulfate. Okay, iron 2 sulfate solution. Okay. So what is the products? Okay. In this case, okay, basically the question will not ask you to write the chemical equation for the reaction 2. Okay, what the question will ask you to do is, okay, they will ask you to write the oxidation and reduction. That one will be easier. So we roughly change it like this. Okay. So first we focus to iron. Okay, iron 2. Okay. Another one is the chlorine. Okay. So during this reaction, chlorine it will undergoes oxidation or reduction class. What it will change to? Chlorine it will change to what? Chloride. Okay. Chloride. Is that okay? So, what is the oxidation number for the chlorine? 0. Then how about this? -1. Okay. 0 to -1, reduction, right? So reduction gain or loss electron? Okay, gain electrons. Remember, reduction gain electrons. Okay. So this one is under reduction. Reduction. Okay. Then, if this one reduction, this one definitely undergoes oxidation, right? Okay. So if oxidation, what you will change to? Iron 3 positive, right? So oxidation gain or loss electrons? Loss. Loss how many? 1 electron. So this one is oxidation. Okay, huh? Okay. Any question? Then for this one? Okay. So chlorine change to chloride also, right? So, this one also reduction, no? So chlorine undergoes reduction in these two set of experiment actually. This one also reduction. Okay. Then the other one will be oxidation, right? So it will be iodide change to iodine, correct? So lost 2 electrons. So this one is oxidation. Okay. So class oxidation and reduction for set 1 and set 2. So all are listed out already. Now we can go to see the question. Okay. Now write the half equation for oxidation and reduction reaction occur in the set 1 and set 2. Okay. So all are here already. Okay. So set 1 reduction, oxidation. Okay. Set 2 oxidation, reduction. So 4 marks already. So altogether how many marks? 6 marks. So another 2 marks. Okay. Change determines the change in the oxidation number for chlorine for both set of experiment. Okay. Sorry, before that, state the observation for test tube in set 1 and set 2. Then determine the change in the oxidation number. Okay. Sorry, I think this one, because the reduction for both set 1 and set 2 are the same, so there is no 0.4 for this one. Okay, so 0.4 will be the observation. Okay. Test tubes. So what is the color change for point number 4? For set 1, what happens to the color change? What happens to the is there any observation you can do for set 1? Okay, potassium iodide solution, what color? Iodine is purple in 111 trichloroethane, right? Potassium iodide, what color? Colorless. Okay, colorless. Then at the end, okay, is there any indicate? Is there any 111 trichloroethane? No, right? No, you won't change to purple color. It will be brown color. Yes. So the colorless solution turns brown. Okay. This colorless solution actually is what? Potassium iodide. It's the iodide ions. Brown actually is the iodine. Okay, iodine. Okay. Now point number 5 in set 2. What is the observation in this? Iron 2, what color, class? Green color, right? This one is green color. Then iron 3, brown color also. Okay. So green, solution turns brown also. Okay. So green solution here is what? Is iron 2 ions. Okay. Brown here is iron 3 ions. Okay. Now point number 6. Change of the oxidation number for chlorine. So it'll be the same, right? From 0 to -1. Okay. So all 6 marks. Okay. All together. Okay, any question? Okay, now we go to B. Okay. Okay, diagram shows apparatus to study the potential difference between 2 electrodes in a redox reaction. Okay. So class, here we have 2 electrodes here. One is magnesium, another one is silver. Okay, silver. So look into the E naught value. Okay. Silver is here, magnesium is here. Look into the E naught value. Which one will become the A naught negative?
The one with magnesium.
Okay. More negative E naught value becomes the A naught. Undergoes oxidation. Okay. Remember. So more negative. So this one becomes the A naught. No? Undergoes oxidation. Remember. Okay. Then the other one becomes a cathode. Okay. Here we occur the reduction. Okay. Now, okay. So what happens here? So magnesium. So what happens here will be oxidation. So oxidation. How is the equation? Can we copy this? Huh?
No.
Yes or no?
No.
Boleh salin kah?
No.
Huh? No. Okay. So what is the correct one? Should be reverse. More to the left. Right. More to the left. So meaning that magnesium, it will produce magnesium ions. Lost 2 electrons. So you always can double check. A naught must undergoes oxidation. Oxidation, you can double check here. Lost electron is 1. Then oxidation number you can check also. 0 to positive 2. Cannot? So if you are confused whether you want to make it to the left or to the right for the equation, so check the oxidation number. Okay. So this is the half equation. So if we change to ions, what can you observe here? What happens to the magnesium electrodes? Jian, what happened to it? Yes, become thinner. Because it changed to ions already, right? So meaning that at the end, it becomes, okay, it becomes thinner. It will be gone. Okay, becomes thinner. At the end, it will all dissolve. If you put it there overnight, it will dissolve all. Okay, now we focus to the cathode. Cathode here. Cathode undergoes oxidation, reduction, right? Okay. So here we will focus to the ions. Okay. So we focus to what ions? In here we don't focus to the N ions. We'll focus to K ions. So we have silver ions. We have hydrogen ions. So which one will be discharge? So we check the silver, more positive one. We'll choose the more positive. Okay. So the one silver is more positive. This one is 0. Okay. So the half equation will be silver gain electrons. It forms the silver. Okay. So what can you observe? Here, silver what color? Silvery metal is formed. But actually if you write gray solid is formed, actually is correct also. But more accurate it will be silvery solid is formed. Okay? Then we can see what is the question already. Okay, now identify which electrode act as the anode. Okay, magnesium, right? Okay. So this one, point 1 is magnesium. Okay, why? Why? Okay, value of E naught is more negative. Okay, then silver. Okay, right? More negative than silver. Pardon? You mean which one? P2? Yeah? Yeah, because you need to give a reason, right? It's 2 marks. Okay, now write the cell notation. Okay, cell notation. Okay, you still remember what we should, the general one, what we should write first? Left side it will be anode. Okay, we write the anode first, then 1 line. Okay, then electrolyte, the ions in the electrolyte of anode. Okay, then double line. Okay, double line shows the porous port or the salt bridge. Okay, it is separated. Okay, then electrolyte of cathode. Then 1 line, then the cathode electron. So here we focus to this diagrams. So what is the anode in this class? In this case, the electrons is what? What is the anode for this case? Magnesium, right? So Mg. Okay, what is the electrolyte?
silver.
Mg. Magnesium ions, right?
Yeah.
Okay, then double line. For cathode is silver, right? So the electrolyte is silver ions. Then silver. Okay, so this is how you write the cell notation. Cell notation. Okay. You can write the physical state. Okay. So far last year is no lah. Okay, but we don't know this year. Oh, better lah. Better you write lah. Never mind. Okay. Now C. Okay. C. In another experiment, a student conduct experiment to investigate the factor affecting the discharge of ions for different electrodes. Okay. So we see. Set 1 use the carbon. Set 2 use a carbon also. What is different? Wait, oh, okay. But here mentioned is different electrodes. Should be different concentration, right? Okay. Never mind. Okay, so class, now we see. Okay, here this one use the potassium chloride. This one use the potassium nitrate. 1 mole per cubic decimeter. Okay. Is considered dilute or concentrated? Concentrated. So which one will affect? Which one will be affected? The chloride. Nitrate will be affected or not? No. Okay. So meaning that now Okay, this one is positive, this one is negative, huh? Anode and cathode. Okay, anode and cathode. Okay, so we list out all the ions inside here. Potassium chloride solution. What are the ions? Potassium and chloride. Solution? Hydrogen, hydroxide. Okay, this one also the same, right? Potassium, nitrate, hydrogen, hydroxide. Okay, class. Now we determine the ions that are selective discharge. Huh? Okay, based on this, the anode and cathode. Okay, for potassium and hydrogen, which one will be selectively discharged? We look into the E0 value. This one and this one. At the cathode. Huh?
Potassium.
Sure?
Sure.
Okay. Which one will be selectively discharged? Potassium or hydrogen?
Potassium.
Huh? The answer is hydrogen. Huh? Hydrogen. Okay. We never choose the for the reduction. Now. Okay, for the reduction, never reduce actually. Potassium ions will never undergoes reduction. Okay, because it's too negative. Okay, it tends to undergo oxidation. No? Okay, so hydrogen will be discharged. Okay, now how about the chloride and hydroxide? Okay, chloride and hydroxide, if we look into the chloride is 1.36, hydroxide is positive 0.4. Okay, if normal case, we will choose what? Hydroxide. But this case, we will not choose the hydroxide. Why? Because of high concentration. We will choose the chloride because of high concentration. Okay? So, beside the chloride, what else we will choose it if the concentration is high? Beside chloride? Bromide. What else? Iodide. These three, but here only chloride. But if you see bromide or iodide, you need to consider the concentration. Okay. Now how about this? Potassium and hydrogen. Still hydrogen. Okay, but this one, nitrate and hydroxide? Hydroxide. Okay, hydroxide. Okay. So even though here is concentrated, but we will not choose the nitrate. Okay? Only these three will be selectively discharged. Chloride, bromide, and iodide. Okay? So what is the question? Okay, compare and contrast. Set 1. Based on what? Based on based on the diagrams. Okay. So this one 10 marks, right? If got the compare and contrast, okay, so we can build a table. Okay, we can build a table to present your answer. Okay, and now let's see how to compare the okay, so now class we look into the comparison. We can make a table like this to present. Okay, so first one. Okay, so ions that are attracted to anode. Anode. Okay, so for set 1 and set 2. So set 1, chloride and hydroxide. Okay, chloride and hydroxide. ions that are attracted, haven't discharged yet. Then point number 2 for set 2, a nitrate and hydroxide. Okay? For cathode, both are the same, right? Potassium and hydrogen ions. So point number 3.
知道是
Okay?
为什么才就是OK
Not attract now only the attraction. Both will be attracted there, but only one will be discharged.
为什么才就是
Because of solution, right? Okay. Now choice of ions to be discharged, discharge. So here for the set 1, okay, and not now will be chloride. Okay, will be chloride. But for set 2 it will be hydroxide. Will be hydroxide. Okay. So meaning that oxidize at the anode here, at anode. Okay. Now you need to give the reason, right? Okay. So for set 1, because the concentration is higher, concentration of the chloride ions is higher. Okay. Then hydroxide ions. Okay. If like this, need to compare, we better use the full sentence. Don't just write concentration of chloride ions is higher. Then full stop. Higher than what? Higher than hydroxide ions. Okay. And point number 7. Why hydroxide ions? Okay. No need to mention about the concentration of nitrate ions is high, but it never be chosen to be discharged. No need to explain that. Okay. If we choose the hydroxide, we just focus to the E naught value. Okay. So E naught value of hydroxide is less positive than nitrate. Enough. Okay. If you choose the hydroxide, just use this reason. Okay. Now observation at the anode, what can you observe? So chlorine, right? So chlorine will be greenish yellow gas released. Then if hydroxide will be colorless bubble gas. Okay, colorless bubble gas release. Okay. For cathode here, colorless bubble gas, because all are hydrogen, right? Okay, hydrogen gas. Okay, so remember, observation do not accept the name of the gas. You don't write oxygen gas release, okay, or hydrogen gas release. Okay, for observation, you must write the color of the gas normally. Okay, so altogether here will be 10 points. 10 points. Okay, we look at the last question. A compound formed through the chemical bonds. Then table shows the result of experiment to investigate the properties of compound X and compound Y. Solid of the compound X and Y are added into water and propanol separately. Okay. Faris, what is propanol? What solvent is it? What is the solvent for propanol? It's called what solvent? Okay? One is water, another one is propanol. Propanol is what solvent? Organic solvent. Organic solvent. Okay, now we see X soluble in water or not? No change. Okay, no change. Then this one in the propanol, it would forms a colorless solution, right? Okay. So what is this X? It's a covalent compound. Okay, covalent. Okay. Then Y solubility in the water, it forms a colorless solution. So, but in the organic solvent, no change. So what is this? It's an ionic compound. Yes. Okay. Now, the question asks, what is the purpose of chemical bond formation? Very, like, we never think of this kind of question, right? Okay. What for? What is the purpose of this chemical reaction?
More diverse.
Yeah, okay. The purpose? Okay, to achieve stable, attack, or deplete electron arrangement. Okay, that is the purpose. Okay, now type of compound X and Y. So point 2, X is covalent. Okay, Y is ionic. Yeah. Yeah. Here you have to mention about the bond. Don't write compound. If you write compound, it's wrong. Okay, but if you write ionic and covalent only, then it's safe. Okay, that. Okay, class. Now we look into question number 2. Okay. Wait for a while. Okay, suggest 2 different elements that can form a bond, such as the compound X and compound Y. Okay, so X and Y, X we know it is covalent compound, Y is ionic, right? So suggest what elements? Okay, so first for point number 1. Okay. Okay, for X, it's a covalent, right? So what is your suggestion? Actually, any covalent compounds can be accepted. Okay, water, H2O can. Okay, what else? Okay, hydrogen gas. Okay. But here we have to see. Okay. If can, we put which suggests the things that is in the solid form. Okay, because here you see got solid ma. Okay. Hydrogen sulfate can, but later your sulfate how to draw because the question asks you to draw. Understand? So don't make yourself trouble. Okay, we choose the simple one. Okay, hydrogen chloride is in the gas form. Gas. Hydrogen chloride. Gas. Okay. What else? What? Iodine. Okay, iodine can. Actually any covalent compound can. Okay, but you see the question asks you to draw the electron arrangement for the bond such as compound X that has been suggested. So you have to be able to draw out the compound. Okay, for example, let's say just now you mentioned is iodine, right? Iodine, the electron arrangement will be very difficult to draw. Okay. So here suggested answer. Okay, we use the carbon. For X, we use carbon elements and oxygen. Okay, later you form the carbon dioxide. Okay, but carbon dioxide also a gas. Okay, never mind. How about Y? Y is ionic, right? What is your suggestion? Sodium chloride can. Okay. Any more? Sodium chloride is the most common one, right? Most common one. Sodium chloride. Okay, let's say sodium and chlorine. Okay, all atom. Okay, next. Okay, point 3, point 4. Okay, we have to draw out the for compound X. Okay, compound X. Okay, so we can draw out this. Okay, 2 marks. So here you can see carbon and oxygen. Okay, this one 2, 4. Oxygen is 2, 6. So share 2 pairs of electrons. for each atoms of carbon and oxygen atoms. Okay, so this oxygen atoms also the same. Okay. Next, the question asked, for the bond such as compound Y, describe the formation of the bond. Okay. Then finally write a balanced chemical equations. Okay. So this one for formation of the ionic bond, we suggest the sodium and chlorine, right? Okay. So 0.5. Okay. Adrian and Faris, what is the first point to write the formation of the ionic compound? We mentioned about? Faris? Adrian? Donation? Before it donates, you need to mention what first? We mentioned about the electron arrangement. Yes. Okay. So first we mentioned about electron arrangement. Okay. So sodium atom. Okay. In here, remember, if you mention sodium only, is wrong. So sodium atom. Okay. Has electron arrangement of sodium. What is the electron arrangement? 2, 8, 1. Okay. And chlorine atom is 2, 8, what? 2, 8, 7. Okay. Class, let's say this one coming out in the exam. So the question asks you to suggest yourself. So how do you know the electron arrangement? You can refer to the periodic table given. Understand? Then from there you can see the proton number. Okay. Then after that, point number 6. Okay. So next, what we should do? What is the next point? Okay. You can mention sodium. Okay, or before that we can mention about what is the purpose of donation and accepting the electrons? To achieve stable octet here, right? Octet electron arrangement. Okay. And point 7. Okay, sodium atom lost, right? Or donate. Donate how many electrons? 1 electrons. To form sodium ions. Okay. Na positive. Okay. So this one is also accepted by equation. Donate 1 electrons. Okay. Will be the same. Then point number 8. Chlorine atom. Here all need to be mentioned. Except 1 electrons. Okay, from the sodium atom just now to form chloride ions. Okay. So this one is, you also can write the equation. Chlorine gain 1 electron forms a chloride ions. Okay. Then point number 9. Okay. Next, after you mention about the gain or loss, then after that, Emery. Oh. Okay. What is the next point? You mentioned about the electrostatic force, right? Okay. So sodium ions and chloride ions, okay, are attracted by what? Strong electrostatic force, okay, to form what? NaCl, ionic compound, okay, NaCl. Sodium chloride, okay. Okay, next 11, right? Another 2 points is the chemical equation. Okay, so balanced chemical equation. Okay, you try first. What is the point 10 and point 11? Okay, can you write out the chemical equations for this formation of the sodium chloride? Okay, so sodium, what is the formula? Yeah, Na, right, is a sodium atom. So react with chlorine, right? Okay, so chlorine, Cl, as this as diatomic, right? So it should be Cl2. Don't it will produce us sodium chloride. Then you need to balance the chemical equation. This one times 2. Then sodium also times 2. Okay? So this is 11 points for this question. Okay, now we look into B. You are supplied with following compounds: sodium oxide, glucose powder, and then solid oxalic acid. Now describe an experiment to investigate the electrical conductivity in an aqueous solution for all the substance supplied. Okay, so how to determine the electrical conductivity? Okay, so we use the, let's say, for electrolysis of the molten state. Okay, so before we discuss this, okay, you have to know already what is the electrical conductivity. Sodium oxide powder can conduct electricity or not? Can or cannot? Solid can or not? Cannot. But how to make it conduct electricity? You add in the water, dissolve it in water, then it can produce the freely moving ions. Okay, not? Then glucose can conduct electricity or not? Cannot. Add in water also cannot, because it has molecules only, right? Okay. Then oxalic acid can conduct electricity or not? In solid state, cannot. But if you add in water, yes. Okay, it can move freely. The ions can move freely. Okay. So here in the aqueous solution, aqueous solution means dissolve in water. So we just need to describe the experiment to investigate the electrical conductivity. Okay. So first, meaning that we need to mention about the procedure. Procedure. Okay. So, okay, 6 marks. 6 marks. So point number 1. What should we do first? We need the water solution. We need to add in the water, right? Okay, pour. Okay, water into beaker. Beaker lah. Okay, until half full. Okay, so for the beaker, right, if you don't know the volume you want to use, you can just say half full. Okay, it's very safe. Okay, not? If normally we can put just 100 cubic centimeter. It depends to you actually. If you use 50 cubic centimeter, definitely you cannot put 100, right? So normally for this case we will use the maybe 200 cubic centimeter of the beaker. So we can put 100 cubic centimeter of the water. Okay, then? So depends to the size of the beaker you use. Okay. Then after that, point number 2. Okay, we can add in action, add in a spatula, right? Okay, one of these, you choose one first. Sodium oxide, let's say. Sodium oxide powder into the beaker. Okay, and stir. Okay, and stir it. Okay, next, after that, point number 3. Okay. Normally, some students, right, they will draw out the apparatus. Okay. And then they will add in the sentence like this. Okay, the apparatus is set up as shown in the diagrams. You don't do this in the exam. Okay, you have to explain it step by step instead of drawing out the diagrams. Okay, don't draw the diagrams and then mention the setup of apparatus as shown in the diagrams. You will lose a lot of mark. Okay, so what to do? We want to do the electrical conductivity, right? Okay, after we have the solution, then we can dip, right? Okay, dip 2 carbon electrodes, okay, into the solution. Okay, and after that, after you have the electrode ready, then we have to connect to wire, right? Connect to what? To battery. What else? Connect to voltmeter or ammeter lah. Or if you don't want to use ammeter, what else we can use to see the electrical conductivity? Galvanometer can, but obvious one, we can use a bulb. Yes. Okay. Yeah. Okay. Connect. Connect the carbon electrodes to what? To battery or to battery first. Okay, to battery and bulb. Okay, using connecting wire. Okay, then complete the circuit. Okay, complete the circuit here means you switch off, you turn on the switch actually. Okay, after that, point number 5. Okay, after all connection done already, you complete the circuit. Then what should you do? Everything done already. What should you do? Observe and record. Remember, so we simplify it. Record the observation. Okay, observation on the bulb, whether it's light up or not. Okay, then point 6. Repeat. Okay, repeat the experiment. Okay, using the remaining 2 glucose powder and solid oxalic acid. Okay, glucose powder and oxalic acid. Okay, powder. Okay, so class, for the experiment, right? Okay, the last two steps here are always the same lah. Okay, you must record the observation and then repeat the experiments. Okay, not?